Okay, and that general rule is that whenever you're graphing exponential function graphs, okay, exponential function graphs, and we're going to kind of put stars by this so that you always will remember it, okay? Exponential function graphs. If you have a y equals something in parentheses that is a whole number to the x, okay, this only works for a whole number inside. Anytime you have something with a y equals a whole number to the x, your equation is always going to be an exponential growth graph. Okay, it will always touch 0, 1, and it is always going to be exponentially growing. All right? The other kind of equation is if you have a y equals something that is a fraction to the x. Okay, so anything a whole number to the x looks like this. This is a fraction to the x. Okay, that type of graph is always going to be an exponential decay graph. Again, it will always touch at 0, 1. And these are your models, okay? So anytime you have to do something that looks like number 3, okay, y equals 4 to the x, it doesn't matter. I don't actually want you to graph that. I just want you to know, okay, is that a whole number graph or a fraction graph? That's a whole number graph, right? So you can know the general form of a whole number graph looks like this. So closest to the x-axis will be what? The smallest number, the most negative number will always be the one that's closest to the x-axis. If you have a fraction graph, then the thing that's closest to the x-axis, the value closest to the x-axis, is always going to be the most positive number. Okay, so the greatest number is closest here, the least number is closest here. Does that make sense? Kind of? A little bit? Okay. You guys will do a bunch of these on your homework today. Okay, but know these two. These two are kind of the templates that you need to somewhat memorize. Okay, you can always draw these real quick, but these are going to be the templates basically for everything, okay, that we're going to work on. The last thing I want to show you is we're going to do one more graph. Okay, I want you to graph, oops, sorry, this is example 4. Okay, for example 4, I want you to graph y equals -3 to the x. Y equals -3 to the x. We're gonna plug into our xy value table. For these, you want to always use x values of -2, -1, 0, 1, and 2. Okay, we always use the same x values. Those are always the ones that you're going to plug in. Generally, I'm going to give you the values, okay? So you're going to have the table, you're just going to have to fill it in. If I plug this in, what would be -3 to the -2 power? That would give you 1 over -3 squared, which is, yes, 1 over 9. What if I plug in -1? What's 1 over, that would move it 1 over -3 to the first power. What does that give you? -1/3. Okay, and negative to a power of 1, to an odd power, keeps it negative. How about if I plug in 0? What's -3 to the 0 power? 1. Okay, how about -3 to the first power? -3. And -3 to the second power? +9. Graph this. Okay, if you look at graphing this, -2 up 1/9, so that's pretty close. -1, -1/3. So it's like down here. Over 0, up 1. Over 1, down 3. and over 2 up 9. If you connect these dots, it's going to kind of look like one of those heart monitor things, right? We don't like these kinds of graphs, okay? Exponential graphs need to be smooth, okay? This graph is not smooth, okay? And by smooth, I mean a nice line, right? This is not a nice smooth line. It is not allowed. Okay? You are not allowed to have anything if it's not a smooth line. Okay? We're not going to have any, you could have something that's a curve, it's nice smooth, but we can't have anything that's jagged like that. Okay? So you can never have the base be negative. Okay, because here your base was negative. It can also never be 0 or 1. Okay, you will have to do the graphs of a 0 and a 1 in your homework. But just know that there's a rule that in math saying you can never have an exponential function with a negative base or a 0 or a 1. And if you think about this like a real world example, let's think about something that's negative. Okay, we're talking about usually something growing or something dying. Okay, if you have like bacteria or a substance that's negative, that means it hasn't been made yet, right? That doesn't make any sense. Okay, you have to have the substance. It has to be positive. It has to be here. You can't have a negative amount of something. That doesn't make sense. So that's why exponential functions do not work. Same reason for 0. If you have 0 money, okay, let's think about this. If we say you're going to put this in like an investment account, okay? An investment account. If you have negative money, how do you expect it to grow? That doesn't make any sense, right? If you have 0 money, it can't grow either, okay? 1 is a little bit easier to think of in terms of like bacteria or molecules, that kind of thing, okay? If you've paid attention in chemistry, for things to react, there has to be more than just one thing, right? Like you could have 2 oxygen molecules, but they like bump into each other and they make reactions and stuff. If you just have one thing bouncing around in the air by itself, it's not going to grow. It's just one thing. Okay, so that's why you can never have an exponential function with a base of 0, 1, or negative. Okay, those are your notes for the first set. Okay. Homework on this is going to be worksheet 2. You're doing numbers 1 through 15. There's only 15 questions on here. Okay, worksheet 2, numbers 1 through 15.